Next is the LPG system or liquefied petroleum gases. So ito yung mga binibili nyo, di ba? Kalutuan nyo, ginagamit nyo sa mga restaurant. Ito, food court. Okay. Yan, papasok yung mechanical plant doon ng LPG piping. Okay. So, ito, in general to, transport and storage. Diba, sa mga refilling station, meron doon sa LPG refilling. So, LPG is supplied to facilities from a tank truck or railroad tanker if the storage is large enough. It is stored on site as a liquid, so up to 17 tons of product. Where usage is large, permanent large tank are installed on the facility property and refilled directly from tanker truck. If the usage requirements are small, small propane tank containing liquid may be installed and the tanks replaced after they are empty. The liquid must be vaporized to produce a gas, depending on the actual installation and flow rate. The liquid can be vaporized in the storage tank mismo using the heat gained through the storage tank wall. Imagine nyo. Or in an auxiliary vaporizer that uses an outside source of heat kung hindi kaya nung tanke. The gas may be used as vaporized or if it is a substitute supply for natural gas. So it may have to be mixed with air to produce a lower weighted thermal unit content suitable for specific application and equipment. As a replacement, so kailangan mo ng mix propane and air the mixture para maging yung piping mo, magamit mo na para sa natural gas. Okay. The storage tank. Tanks used for the storage of propane are made of steel. Tingnan pala, yung natural gas, so marami doon methane. Ito naman sa storage sa LPG is propane. Okay? Propane gas at LPG gas. They can be installed either above or below grade. Although underground tanks have an advantage of more constant environment, most tanks are placed above ground because of the lower initial cost and EPA requirements. Environmental Protection Agency. So ito yung vapor pressure of butane propane mixture. So kung kayo sa chemical engineering, ito yan. Yung table na yun, pinulugay ng masa. Or ito yung mixture na propane, butane, then ayan, mga mixture yan. Propane, butane mixture, and then yung properties. Diba? Okay. Ayan. Okay. So yun. Because of the relatively high pressure developed by the propane vapor, all tanks must be designed in conformance with the ASME code for unfired pressure vessel. So the vapor pressure developed in a above-ground tank is based on the ambient outside air and can be found from figure 1. So the temperature, yung mixture mo kung 100 propane na ito yung vapor pressure that is 50 psi. So malaki, di ba? Mabab siya pag may mixture ng butane. Ang butane kasi ito 100% butane. So for underground tanks, a figure of 50 Fahrenheit or 10 C is used. Ito yung surface Earth. Diba yung buhangin? Pag mga underground, ano yung temperature ng buhangin? So ina-assume nyo na 50 Fahrenheit or 10 C. So typical capacities of large standard tanks are shown in figure 2. So dito yung capacity in gallons. I mentioned like fire spacing, ito. Yan, sa tukod. So estimated weight. So may kita kayo sa mga plant sa petroleum refilling tank. Lpg refilling plant natin sa meron dito sa people. Makikita mo yung dito. Kaya lang yung dimension, hindi mo susunod kasi may kanya-kanya naman yung manufacturer niyan. Okay? Pero ito is a guide only. Estimated weight, yan. Okay? Para sa foundation. The dimension and capacity of a smaller standard tank are summarized in Table 1. So dimensions vary slightly from manufacturer. So itong 120 gallons, with propane capacity, yan. Hindi pa ito yung ginagamit natin, malalaki ito. Yan. Surface, total surface, weighted surface. For non-standard tanks, Figure 3 contains a simplified method for calculating the areas of the tank with various configurations. Containers in storage tank are referred to as Department of Transportation DOT cylinders, generally portable, or ASME tank, generally stationary. In the following discussion, all capacities referring to gallons are gallons of water, and all weights are weight of liquid propane, unless indicated otherwise. So gallons of water is the same as gallons of liquid. Pero din lang, volume yun eh. Okay? Ano silang. Ito yung tank size, ito yung laman. Yung propane. Okay? Check nyo rin yung mga latest ngayon sa Lpg tank. DOT cylinders range in size from 1 to 420 pounds capacity. Cylinders built in 1966 or earlier may bear the Interstate Commerce Commission ICC designation as the tank range in size from 500 to 60,000 gallons. The maximum content of liquid in tank. So the maximum allowable quantity of LPG permitted in a container is limited by NFA 58 to a filling density based on table and formulas provided in that code. Check nyo naman doon. So location of equipment on site. So the factors to be considered in locating the equipment are, so the code requires clearance from other building, property lines, and any other equipment. These clearances also depend on insurance carrier requirements and client preferences. Factory mutual requirements indicated in Figure 4 are considered conservative. This is the Figure 4. Clearances from propane tank to a building or other structure. So dito yung tangke mo. So meron kang vaporizer. So yung distance niya yung H. Point to point distance is 15. Or in meters, 4.5. Yeah. So ito naman mga railroad car, unload, distansya. Next tank, yung spacing is 75 feet or 23 meters. Yan. Yan. Yung mga distansya niya. Huwag yung pagkasayin yung lote. Hindi, huwag lang kayo kung sila mag-install. Ito yung building. Openings, E, distansya ng direct current is 15 meters. Ayan, nalayo niya, di ba? So A is 75, 100, 200, nalayo. Yan. Point to point, number 8, 9, 10. 8, 9, 10. Ito. 3, 4, 5, G. So letter G, hanapin mo yung 3, 4, 3, 4, 5, anong capacity? Yan. To 6. Yan, 3, 4, 5, 6. Yan yung capacity. So meron ng distance dito. Letter G. So 1, 2, 3, A. 1, to so sundan nyo na lang A. Yan mga rules. So tank foundation and support. Yung fires. Tank foundations must provide a stable means of support. Uneven settlement will lead to errors in fuel gauging and stress leading to broken lines. The weight of tank should be calculated using water since there may be a requirement for hydro testing during the life of the span. Yung iba, nakita ko noon, nakalagay na weight is pang design sa foundation, ginamit yung talagang content. LPG. LPG ang ginamit, hindi. Dapat tubig. Kasi mas mabigat yung tubig para sa fondasyon. Ibig sabihin, pag ginamit mo yung LPG, tapos naka-test ka, lulubog yung foundation mo. Some larger tanks may require an approximation of the gross weight of a steel tank can be obtained by multiplying the capacity in gallons by 11 for water and 6 for propane. Some larger tanks may require a temporary intermediate center support during the time they are filled with water for hydrotesting. So ito, pag may hydrotest ka, so dagdagan mo ng support. Kung dinis-design mo isa weight ng propane and LPG. Regulators, marami na nakikita nito, di ba? So, the gas regulator, LPG regulator. The regulator for LPG is different from that used for natural gas service. So the purpose of an LPG regulator is to reduce a variable inlet pressure to a constant outlet pressure after variable flow conditions. So the following information is required to size a regulator. What is the minimum significant and maximum flow rate possible? The maximum and minimum container pressure, required outlet pressure desired, manufacturer's rating curves for the regulator. So ito yung table 2. Andyan regular delivery pressure, and the lift valve start to discharge pressure setting. So ito. So the pressure developed inside the storage tank is produced by the vaporization of the product inside the storage tank. The pressure is called the vapor pressure. This figure varies depending on the ambient temperature. And figure 1 is a direct reading chart to determine the vapor pressure for various mixture of propane and butane that might be provided by supplier. Regulators are manufactured in single and double stage model and are selected using the capacity and rating storm supplied by the manufacturer. If a relief valve is provided as part of the regulator assembly, refer to table 2 for pressure setting. Delivery pressure times 2 mo, so ito na yung settings mo. 1.4 times yung delivery pressure mo, yun ang settings mo. Mas relief valve. So experience has shown that when regulators are kept in service longer than 15 years, the probability of malfunction increases. This figure is only a generalization, with actual climate and service conditions playing an important factor in the service life of general regulator. So ito yung mga regulator. The propane gas regulator is one of the most important part of a propane gas system. The purpose of regulator is to control the flow of gas and lower the pressure of the tank to the appliance in the system. The regulator not only acts as a control regarding the flow and distribution of propane, but also as a safety barrier between the high pressure of the tank and the end-use appliances. Most will rightfully argue that the LPG gas regulator is the heart of any propane gas system. Relief devices. So the purpose of a pressure relief device is to automatically vent propane vapor to atmosphere upon reaching a predetermined high pressure. It can be an integral part of a pressure regulator, separately installed in the storage tank, part of vaporizers and mixers, or in the piping system itself. So the relief valve flow capacity is calculated on the basis of a full tank and the resultant vaporization of that volume of propane. For an underground tank, the capacity will be 30% of the above ground value. Refer to Table 3 to determine the required flow of propane based on the square foot area of storage tank by use of figure 3. So this one is the capacity of the Table 3. So relieving capacity on tanks in vaporizer surface area. Then makukuha mo yung flow. Yung sa relieving capacity. Then figure 3. Ito. Yung area niya. Makukuha mo. Tapos dito hanapin mo yung relieving capacity. Anong area na kuha mo pag may katapat yan na flow rate. This is for above ground. Then 30% yan is underground. Okay. Flow, CFM air. Yung relieving capacity, yung relief valve. Pressure relief devices. Right? All larger tanks must have a separate relief valve installed directly on tank. If a single relief valve does not have the required flow capacity, it will be necessary to have multiple relief valve mounted on the top of the tank to provide the necessary flow rate. Kapag ito mga tank, ay dami accessories niyan. Taas. So it will be necessary to have a typical tank relief valve which is illustrated in figure 5. Ayan. The final pressure setting of the relief valve is normally 88 to 100% of the design pressure of tank with a permitted error of plus 10%. Excess flow valve. An excess flow valve permits the flow of vapor or liquid in both directions but shuts off the flow of liquid or vapor in only one direction when the flow exceeds a predetermined unit. It is recommended that an excess flow device be placed on all connections to a larger tank except for the safety relief valve. The failure connection should have an integral valve. The capacity is calculated from the largest expected flow and its mounting position, horizontal or vertical. Valves are selected to open at 150 and 200% of the expected maximum flow. Service line valve. The service line valve controls the flow of propane from a DOT cylinder. This is a multi-purpose valve that could contain a set of valve, relief valve, gauge, and filler valve all in one body. Okay. Ang dami yan. Filler valve. A filler valve, so yung, fill. Nalagyan mo ng laman. A filler valve permits the flow of liquid in one direction only. It is used for filling larger tanks with liquid. This valve contains an integral back pressure check valve that will prevent the loss of vapor or liquid from the tank if the fill hose or fitting ruptures. A preferred location is at the filling connection used by the delivery truck hose. So, vapor equalizing valve. When large tank are filled, the liquid propane added to the storage tank compresses the vapor in the tank. A vapor equalizing line is connected between the vapor area of the receiving tank and the vapor area of the delivery tank during propane deliveries to equalize pressure in both containers and to lessen the head requirement of the supply pump. The vapor equalizing valve is mounted in the equalizing tank track hose connection. It permits the flow of vapor both ways. Ito yung sample. Liquid level gauges. So when a larger tank is filled on the basis of volume, It is important that the liquid level gauge be installed on the tank to indicate the exact liquid inside. There are several types available: the slip tube gauge, magnetic float gauge, rotary liquid level gauge, fixed level gauge. Yung subject ng instrumentation, yan. And miscellaneous equipment. In addition to the devices indicated, it is often desirable to install a liquid temperature gauge and pressure gauge on a tank to aid in diagnosing any potential problem. So next, vaporizer. Ito yung parang pump. Nag-increase ng pressure. Ito naman is para mag-vapor. A vaporizer is a device that converts liquid propane into vapor in larger quantities than would be possible from ambient heat alone. It is required when sufficient quantities of liquid propane inside the storage tank cannot be vaporized quickly enough to satisfy the maximum demand. So there are two basic types of vaporizer, direct fired or indirect fired. The direct fired vaporizer uses the propane itself as fuel for the direct flame. It has the lowest initial cost and no ancillary power requirement. Its advantages include the problem of pilot light extinguishment in high wind, production of sludge in the propane being vaporized, and a useful life expectancy of only 5 years. And optional accessories to be considered would be an automatic ignition, manual drain, liquid strainer, and propane air mixer. An indirect type of vaporizer is available that uses steam, like a water bath, or the lesser use electric resistance heater as a heat source. So ito yung sample ng propane vaporizer. Propane mixer, ayan. Yung mga nozzle dyan kasi yung air and propane, mag-mix siya. Papasok yung air, yung propane dyan sa maglabas ng mixture. Diba? A mixer, also called blender or proportional, is a device used to combine propane and air together into a mixture of both gases. It is required when propane will be used as a direct substitute for natural gas because the much higher British thermal unit content of 100% propane will not allow the use of the same burner or refuse and gas train as natural gas. So experience has shown that a mixed gas of 1450 BTU per cubic foot with a specific gravity of 1.3 provide the best burning characteristic. To refer to table 4 for properties of various mixture of propane and air. So itong mixture na to, ito yung properties na makaproduce and is the same sa natural gas piping. Ito yung properties of various propane and mixture. Yan, mixture siya. So dito sa 1450, ito yung ginamit natin. So LPG system design. Dito na tayo sa size. Introduce na yung mga parts. Prior to sizing component, initially decide what equipment such as pump or vaporizer may be required and if the tank is to be above or below ground. And select the proposed location of the tank and other required equipment on site. So determine if the propane system will be in constant use or used only periodically, such as for emergency operation or as an occasional substitute for interrupted natural gas. And calculate the maximum hourly and daily fuel gas demand and determine if this demand is continuous, such as not for a process used all day or intermittent, such as not used for heating purposes. If only a small part of the demand is continuous, the entire load should be considered continuous. The storage tanks, sizing, and selection. So the storage tank volume is based on one of the two factors. We have a reasonable return schedule for the local supplier on the amount of liquid propane that has to be vaporized by the ambient air in order to satisfy the maximum demand. Vaporization directly from the tank, if economically feasible, is used to avoid having to add another mechanical device like a vaporizer that requires constant maintenance. If a single tank size to optimum criteria will not provide the required vaporization rate, a single oversized tank or two smaller separate tanks are often installed if space conditions and initial costs are acceptable instead na vaporizing. Tank based on return schedule. Using the return schedule, a preliminary starting point for determining the aqua capacity is a 10-day usable supply for continuous demand and a 3 to 5 days usable supply for intermittent or standby purposes. Ganito, yung rate mo, i-multiply mo sa 10 days, so makukuha mo na yung size ng tanke. With the maximum propane level based on the maximum quantity or the allowed filling density and the minimum level between 10 to 15% of the capacity, the usable tank capacity is about 75% of the total tank capacity. So yan. Kung ano yung na-compute mo, i-divide mo ng 0.75, yun na yung tank capacity mo. 10 days, divide mo ng 0.75, so tank size based on vaporization rate of propane. So when using the vaporization rate as the critical factor in selecting the size of the storage tank, the tank must be large enough to vaporize the maximum flow rate of propane required by the facility when the outside air temperature and liquid level are at their lowest. For above ground tanks, the rate of vaporization is calculated using the weighted area of the liquid propane in the tank. For underground tank, the entire area of the tank is used even if the tank is partially full. So there are two methods that will be discussed. The first and most accurate will use various formulas to calculate the weighted area of the tank that will vaporize the required amount of propane. The second, although slightly less accurate, is the direct reading of the vaporization rate from preferred charge. This is more conservative method and by far easier. Formula method muna. Using the method, the weighted area of the proposed above ground necessary to vaporize the required amount of propane will be calculated. If an underground tank is proposed, the calculated area shall be that of the entire tank. So the basic formula are as follows. So the total heat is equal to the total heat of vaporization from above ground is Q is equal to UATD. For below ground tank is UA times 50. To transpose to find the weighted area, so A is equal to Q over U times TD or 15. And the actual amount of propane vaporized is B is equal to Q over L, where Q, the total amount of heat required to vaporize quantity of liquid propane. U is the rate of heat transfer through the wall of a steel tank per square foot of weighted area where temperature differs in Fahrenheit. Generally accepted figures are 2 for above ground and 0.5 for underground. A is equal to the weighted surface area of the above ground containing liquid propane or the entire surface around area of underground. TD is the intended difference in temperature between the ambient outside air reached during the coldest part of the day and the temperature of propane in the tank reached during the warmest part of the day in Fahrenheit. One factor that must be taken into consideration is the formation of frost on the outside of the storage tank. Since frost acts as an insulation, its formation must be avoided. The table 5 gives the minimum temperature difference to avoid frost formation. With predicted conditions and outside the figures required to enter the table, use the true temperature difference. Yeah. So 15 is 15 Fahrenheit, which is the generally accepted temperature difference for underground tank. B is the mole propane vaporized under the same conditions gallons per hour. L is the latent heat of vaporization of propane BTU per gallon. This is the amount of heat required to change liquid propane to vapor sa table 6. Interpolate to find intermediate values when necessary. Ayan, table 6. When the temperature mo, meron siyang BTU per gallon. So the following methodology is used to select a tank with propane vaporization rate as criteria, solving for equation 3. Step 1, establish the lowest predicted ambient air temperature, highest predicted relative humidity, and required propane gas demand in BTU per hour. Number 2, convert the British thermal unit per hour demand into gallons per hour. Table 7. Table 7. Ayan. Tapos natin table 7. Ayun. Ito. So, transpose equation 4 to find Q. Refer to table 6 to find L. For substitute all figures in equation 3 and solve for weighted area. After calculating the minimum area, consult manufacturer's catalog for size required, providing that figure with minimum level of propane in the storage tank. Select a standard tank with a slightly greater volume than calculated, than that calculated. If a single tank selected for adequate vaporization results in a size that is impractical, two tanks can be used. If the tank are still too large or have too high an initial cost, the only solution is to provide a vaporizer. Next, direct cleaning method. Ito. Yeah. Table 8 provides a table for determining a direct cleaning of propane vaporization from tank. Figure 6, ito, propane vaporization for small tanks. Ito niya. Ito yung capacity. Ito yung capacity in pounds. So dito kapipili ng vaporization area. The figure 6 provides a nomogram for direct cleaning of propane vaporization from larger tank. Take doon sa lecture, meron doon example. Ito yung example na ito. Basahin niyo yung example. Both table 8 and figure 6 are based on a tank 25% full. Reduce the figure by 10% to approximate tanks 15% full. Ito, example. Okay. Basis of calculation, tank 25% full. Wind velocity 5 meters per hour, latent heat 175, average for set and negative 395 night, stable. Tanks is horizontal and spherical. Now, tanks, yung volume ay D. Ayan, gross weight. Ano ito yung mga tank sizes? Example, yung na pa ng mga dimension dito. Okay. Find vaporization rate for 30,000 gallons tank at 0 degrees ambient temperature and 10 psi gauge tank pressure. So draw a line from 0 on a scale 1 to psi. Scale 1. Yan. From 0. So yung 0. Ito. So draw a line from 0 on a scale 1 to 10 psi gauge. Ito. 0 from 1 to 10. Ano 1? This is 5 na yun, di ba? To 10. 160 psi. 0 Fahrenheit to 10 psi gauge on scale 2. Pagbasa ko 1 to 10. Okay. Scale 1, then 2, 10 psi gauge on scale 2, 10. 0. So gawa ka ng line. Lalabas mo sa scale 3 is 28. Diba? Yan. Lalabas dito is 28.8. Yan. 26.8 pala on scale 3. So basa mo na. From 26.8, scale 4, draw a line to 30,000 gallons. Ito. Yan. Scale 4. Scale 2 on scale 5. Dito ka, 28, 6. Gawa ka ng line na punta doon. Ito 10, saka 0, 20. Tapos, tama ito. Mula naman yung 26.8 linya ka naman dyan sa 30, pasilin dyan. So, lalabas yung vaporization rate of 1750. Standard CFS of 48 on scale 6. Ano nangyari? 30,000. Tapos punta ka doon. Yeah. 26.8. Dito, estate mo doon. 48 siya. Wait, Okay. Ito pala. From 26, nakuha natin dito, scale is 26.8. Tapos lipat ka dito. Scale 4. 26.8 din. Tapos 30,000. So yan. Gawa ka ng line dito. Hindi pala yun. Ito, transfer lang. Pares lang itong dalawa. Yan. Tapos, gawa ka ng line, 26.8 to 30,000. Makikita mo na yung 1750 CFS on 48. Ayan, 48. Okay? So, ganyan ang pagbasa niyan. Makuha mo na yung vaporization rate. Nomogram. This is the minimum pressure that is required upstream of the regulator at the storage tank to satisfy the maximum fuel requirement. Yung asterisk. Okay. So, next. LPG gas pipe sizing method na. So, a widely used pipe sizing method for low pressure 100% propane gas system rely on the tables used for NG and NFA 54, such as that appearing in table 9. So ito, same din. Proprietary charts are available that are less conservative and more accurate. So sa ibang discussion, mayroon ang delay yung PPT. Dito, sa handbook na binasya ko, ito ang lecture niya. For use with propane, a conversion factor of 0.63 to reduce the indicated flow rate must be used. So ito, ma-reduce. So, multiply mo ng 0.63 flow, hindi na siya pang gas, kundi pang LPG na lahat to. So propane is often mixed with air to provide a direct substitute for natural gas. Field experience has found that if mixed gas with the same British thermal unit value, 1000 BTU, 1050 BTU per cubic feet, as a natural gas is used, the mixture will not burn properly. As a result, it is common practice to provide a mixed gas with a value of 1450 BTU per cubic foot. This mixture has a specific gravity of 1.3. Since gas flow varies inversely as the square root of the specific gravity, a conversion factor can be used with readily available natural gas charts to size the mixed gas natural gas piping system. The conversion factor for 1 for 50 BTU per cubic foot mixed gas is 0.69. For 100% LPG, this is 0.63. So which is used to multiply the capacity found in natural gas table in order to convert the chart figure to actual mixed gas capacity value. So the method of using the chart is previously discussed for natural gas sizing. So the same. Kaya like, convert mo to sa mixed gas or 100% propane. LPG pump. There are two commonly used pumps in LPG service. LPG pump, liquid liquid. Para sa liquid yan. Iba yung sa gas, that is vaporizer. So there are two commonly used pumps in LPG service. Sliding main, positive displacement, and the turbine, regenerative centrifugal. In general, the sliding main positive displacement pump is generally used for flow of from 40 to 350 gallons per minute. Turbine regenerative pump is generally used for constant flows and pressure when the flow is less than 40 GPM, such as those used to fill propane tank for home use. Either type of pump could be used for any pressure for which it is rated. To calculate the pump head are the following. 1. The vapor pressure of storage tank into which the liquid propane will be pumped. If there is a evaporator line, this will not be a factor. 2. The friction loss of the liquid to the piping network. Refer to table 10 for the friction loss of liquid propane through steel piping. Table 11 provide the losses to fittings and equivalent feet of steel pipe. So ito yung mga ano, ito yung resistance, friction ng LPG sa pipe. Sa fittings naman niya, ito. Okay? LPG ang lumadaan niya. So, 3. The friction losses of liquid propane through delivery hose in pounds per square inch is referred to table 12. So, hose. Di ba yung mga hose ng LPG? So, yan. Di ba kasing metal made yun? So, ito naman yung hose. Friction. Resistance in feet. The pressure drop in PSI. Yan. Okay, kompleto na yung data mo. Now, sa mga iba pang fittings, that's manufacturer na lang. Static head difference between the supply and the setting point. Yung elevation. The resistance to flow from meters, filler valves, and so on. Obtain this information from manufacturers. 6. Add all pressure obtained from step 1 to 5 and add 10% to have some additional pressure available. This figure is the total head requirement for the pump. The flow rate is determined from the specific application. The piping material are the same as the Lpg system. Table 10, 11, 12, and ito na yung mga schematic diagram ng mga LPG service pipe works. So ito yung tanke, stored as 6.9 bar, isolation valve, punta na sa underground kasi malayo yun pasok sa building. Ito na. Vent, pressure reducing valve, so andyan na yung mga accessories mo. Ito na yung appliance mo. Lahat siya may mga isolation valve para pag natanggalin mo, hindi maano yung system. So example, design problem number 1. Design and okay. A mixed LPG air system as shown. So the same din yung sample natin, di ba? Pero dito, mix of LPG and air. So given piping system of LPG air pipe sizes. So sa LPG mixture ng air, ito ang gagamitin natin is 1450 BTU per cubic foot. So, di ba? So, itong mga rating mo na 30,000 feet per hour, divide mo na 140, 50, yun na yung cubic feet per hour mo. Okay? Discuss na natin itong mga length. Bakit doble? Ito. Yan. So, divide. Sige lang. Divide by okay, wait. So, yan. Okay. Divide BTUR by 1450. So, magiging 30,000 divided by 1450 is 21. So, pwede nyo itong idagdag doon sa procedure. Insert nyo paano nakuha yung gallons. Yung CFS dito. Yan. Pero basta importante, nandun lahat ito. Procedure na yan. Pwede nyo insert dito pagkuha ng ito 55, 30, paano nakuha. Yan. Yan. Ito kasi summarize na. So, outlet B, 25,000 divided by 1450 is 17.5 cubic feet per hour. So, outlet C, 65,000 divided by 1450 becomes 45 CFH. And yung 150,000 BTU per hour ng outlet D, divide mo ng 1,450 is 104 CFS. So, drawing nyo to. Kailangan to sa solution nyo. Bakit ba nawawala? So, wala na akong chichikan. Balik na. Then, divide CFS for LPG emission by 0.69 to get the equivalent natural gas piping system. So, itong 21, i-divide mo ng 0.69, magiging 30. Ito naman, 17.5, divide mo ng 0.69, magiging 25. Next line ko, ito naman 45, divide mo ng 0.69, magiging 65. Ito naman 104, divide mo ng 0.69, magiging 150. Yun. Nag-guess nyo. Parang pare siya doon sa naging 30, sa 30,000, naging 30, di ba? So, equivalent na to. Then, use table 9, low pressure gas piping. Schedule gas pressure, 0.5 PSI gauge. Pressure drop, 0.3 inch water column. Based on 0.6 specific gas gravity gas. So 1, to determine the gas input for each appliance, use table or nameplate on appliances. Already given na. Determine the length of pipe and gas meters to each outlet. If length falls between length shown, go to next higher column. So, sulat nyo ulit pag tatanggalin. Number 3, figure, gumagawa kasi step by step. Figure the lateral pipe sizes for individual appliances. So, ito na yung kinonvert mo na equivalent natural gas. Yun ito na yung mga CFF na gamitin mo para doon sa figure, sa table. Outlet A, use 60 feet column demand load, 30 CFS. Minimum pipe size is 1 amp. Wala ba dito? Yan. 60 and 30. So, 50 na siya. So, 1 amp. Okay. Tapos, outlet B is 25 CFS, 38. Outlet C, 65, 3/4. So, 40, 1 inch. So, figure the size of the main pipe feeding more than one appliance. Go to the most remote outlet. It is 60 feet from the meter, so use 60 feet. Then, determine various pipe sizes based on the load for each section. So, section 1 serves outlet A and B. Total is 55. So, unsize P-force. Okay, narinig nyo na to, di ba? Doon sa natural gas topic. Yan. Panas-panas lang siya. Kasi kinuha nga natin yung equivalent. Yan. Final layout. So, ito. Kailangan nyo itong i-submit. Dito ako mag-check. Complete. Complete at yung nakakalimot, ang CFS mo dito, ito yung una mong ginawa. Yan. Pagbalik inagay mo, so hindi mo alam yung ginagawa mo. So, 21, 17.5, 45, and 104. Hindi 30, 25, 65, 150. Kasi iyan, natural gas. Ito, yung mixture of LPG and air. So, ito yung value niya. Okay? So, yan. Next, number 2, design naman tayo ng 100% LPG piping system. Tingnan natin yung kung ano yung pagkakaiba. So yan, divide by 2550 BTU per cubic feet. Saan galing to? Ito yung LPG mo, 2550. Napin pa natin. Ayan, That is 2520. So ginamit natin is 2550. Okay? Yan. So book is 2550. Okay. So divide mo yung 30,000, divide mo ng 2550 is 12. Outlet B, 25,000, divide mo ng 10. 2,550 is 10, di ba? So, yung tamang round off nyo, yung round off na mali. Okay? Baka, ito 26. Okay, that is 65,000 divided by 2,550 is 26. Okay? Pag-compute ko nito, 24. So, 24.5, ginawa yung 26. So, hindi yun, mali yun Hindi yun round off. 25 and above, 25.5 so 26. Okay? 25.1, pwede yung 25. Okay? Ang round off nyo, alam nyo ang rules ng round off. 1.5, so ano yun. So, divide CFS for LPG by 0.63 naman dito to get equivalent natural gas. So, outlet A, 12 divided by 0.63 is 19. Ito naman, 10 divided by 0.63 is 16. Ito, 26 divided by 0.63 is 42. This one, 59 divided by 0.63 is 94. So, ito na yung gagamitin mong value sa table. So, dito ka na. Then, use table 9, low pressure gas piping schedule. Gas pressure, 0.5 PSI gauge. Pressure drop is 0.3 inch water column based on 0.6 specific gravity, yung table. 1. To determine the gas input for each appliance, use table or nameplate on appliance. Already na, given. Number 2, determine the length of pipe from the gas meter to its outlet. If length falls between lengths, should go to the next. Ayan. No? So, length doon, between lengths na 40, 60, nakuha mo is 55. So, between lengths yun, between length of 40 and 60. So, yun. Doon ka sa 60. So, figure the lateral pipe sizes for individual appliances. So, outlet A, use 60 feet column demand load. 60 feet ang pinakamaba. 19 CFS, the minimum pipe size is 19. 60, 19, so hindi pwede yun dito sa 12. 27 ka, so 38. Next, 16, 12 yung ano, ito, so dito ka pa rin sa 38. Ito naman sa 42 CFS, 60 feet 42, dito ka sa 1 up kasi lampas na yung 27. Okay. And use 40 feet, column demand load, 94 CFS sa 40 feet. Yeah. Then 94, so that is 3/4. Okay. Figure the size of the main pipe feeding more than one appliance. Go to the most remote outlet, 60 feet. From the meter, so use 60 feet. Pag ito 55, so use 60 feet pa rin. Okay? Determine various pipe sizes based on demand load for each section. So, section 1 serves outlet A. Take note pala, baka mag 60. Actual nito is 55. So, kaya naging 60. 50 and 60. Okay? So, section 2, ito, A and B, add mo yun. 19 plus 16 is 35. Pipe size is 1 half. Ano yun? 35, 60, 35. So, 1 na pa rin, tapos 67. Yan. Ganun din dito sa section 2, 77. So, pipe size mo is 3/4. All outlet, 171 CFS, minimum pipe size is 1 inch. So, finally, ito na yung pipe sizes mo. Lagyan mo dito ng pipe size, 1, 3, 4, 3, 8, 10. And the value, ilalagay mo dito, 30,000 gallons. Yan, distansya. Pati ito, importante yung solution mo, yung answer mo na 12 CFS. Hindi itong 19. Kaso kopya ng kopya, kinopya naman ito. Madami nag-i-error. Okay? So this is the end of this topic, liquefied petroleum system.